Round was way too slow. I don't know if you've seen the project before. It's the second most viewed video on my channel, but I made an app for voting on which Pokemon is roundest. And I built it using all of my favorite technologies, in particular heavy on the tRPC, Vercel, NextJS, and Prisma, and all my favorite things in the T3 stack. However, those things are great for applications that have lots of features and different behaviors, and you want to scale both the developer side and the infrastructure side really, really far. You might not have the requirements for that project ironed out fully. It's a very flexible stack, but it does not offer the best possible performance once you've ironed out all of the edges and there isn't flexibility. If you know exactly what you want and you have limited enough constraints, you can optimize in ways you otherwise probably shouldn't. And to be frank, a lot of what we're about to cover is things you probably shouldn't do. That all said, I'm really proud because I did make Round 100 times faster by using some different tech and optimization strategies to make it as fast as reasonably possible. Let's get to it. The first, I should probably just show what the project is that we're talking about. This is Roundest. You saw it took a bit to load there. It's between 1 and 3 seconds, even though I'm in San Francisco, because of the cold start times. This is the app that we're talking about. Seemed very simple, loads very slow. These are Pokemon that load in that you can vote on for which one's most round. You'll notice that it fades out and takes a bit to fade in. That's because I'm blocking on the images loading as well as the fetch to get the next 2 Pokemon. Right now, these Pokemon are fetched from the back end. We make a request, and then we get back the data for these 2 Pokemon. That includes their ID, their name, and their image, and then we render all of that. There's a video up. It's pretty old before I knew how to stream, so it's a little cringe, but it does show from scratch how to build an application like this using the T3 stack. All of that said, because of how limited this problem is, we made it... Because of how limited this problem is, the flexibility of the T3 stack is not optimal for it. And I honestly made a lot of decisions there that would work great if like the number of Pokemon could change and like the database was being updated and lots of other conditions that don't exist due to the limited scope of this app. So given the exact state of this right now, which is Pokemon 1 through 493, rendering and being votable, this is a suboptimal solution by a lot. So how can we make this more optimal? Well, the first thing we need to do is get off of Lambda, at the very least for the first fetch. Having to wait for a full refresh from a Lambda function that is a cold starting, possibly 3-second thing isn't going to work. So we either need a static asset or an edge render. Whenever I'm doing either of those things, I tend to use Astro. So the first move I made was starting from scratch with Astro.js, realizing we're definitely going to need an Excalidraw for this. Shout out Excalidraw, !Excalidraw in chat for 30% off your first 3 months. Super hyped. They gave us their first ever like referral code. So definitely take advantage of that if you're interested in the software that we use for all of our diagrams on stream. Fantastic stuff. I absolutely love everything Excalidraw. Anyways, switch to dark mode so y'all don't harass me. How I made Round faster. Roundest.t3.gg stack. And faster round stack. The roundest stack, T3, there is just the T3 stack. I'm gonna horizontal align this so I get less annoyed typing. It's the T3 stack, which means it's NextJS, Vercel with lambdas, Tailwind, Prisma, and planet scale. So like, yeah, this is the original stack. The first thing I swapped out I need to come up with a good name for this stack. Unnamed faster stack. First, we're swapping out Next for Astro. It is possible NextJS will get to the point where you can do a lot of these things. It is not there right now. The combination of the not quite there yet edge runtimes, the not great performance on those edge runtimes, and the gigantic JavaScript, like, how do I put it? Just a gigantic JS bundle that it is going to ship around 150 kilobytes. We don't need any of that for how simple this app is. I should actually put another thing in here, React, because I don't need all of React for this. And I wanted this to be as small as reasonable without compromising my DX for the simplicity of the app. So we used Preact instead. Preact, for those that don't know, is a as close as possible React clone. That's goal is replicating the React API in as small of a bundle size as possible. It doesn't have like deep support for all of React's core features, and there's a lot of like React packages you can try and use here that aren't going to work, but we don't need much. So we used Preact to build this in a smaller, minimal, and more performant way. I saw a mention of chat being more cursed, but I didn't see the more cursed chats until after you said that. Deno has Preact bundled in it. Might be within like top 3 dumbest messages someone said in chat. I'm sorry for calling you out. Yeah. Anyways, back on topic. Unnamed faster stack. Just realized I'm covering that. I'm dumb. Cool. So Astro and Preact are the core front-end tech. We're still using Vercel because I'm not going to compromise on that, but we're using Vercel with Cloudflare Edge workers, which means that they start up way faster. We don't have to deal with the cold start times, and we are limited in what we can and can't run. I ran into some fun problems with like a UUID package refusing to work because it expected crypto. Total mess. Somebody mentioned I forgot tRPC. That's a very good point. tRPC. So what am I using instead of tRPC? I'm using Astro plus routes without type safety. This is one of the bigger compromises I made is I lost the type safety on the fetches. I maintained the type safety for the components in like the initial render, but I've given up type safety for the fetch stuff, which is fine when you see how I architected this. It's not as big of a loss as it seems. You'll see in a bit. Still on Tailwind. No reason to compromise on that. That it already tree shakes to the smallest possible thing. I went without Prisma. I used Planet Scales, database, JS, and I'm hitting the Planet Scale HTTP API instead of the Planet Scale DB driver direct. So this is the difference in the stack. Want to see how it performs? So first we're going to go back to Roundest. Since y'all are going to it, it's going to be called, there's going to be a warm start. So it's a little faster than normal, but you can see how much time there is between the loads. However, faster round, you'll notice page loads instantly. The pictures take a bit. That's because I'm Command Shift R-ing so that I clear the cache on every attempt. But it is instantaneous. Also, I have this on .t3.gg. I don't need to use that URL anymore. But that's also going to break the cache, which is fine. But you'll notice once we start voting, the next thing loads in instantaneously on click. So I'm clicking now. I'm clicking now. I'm clicking now. And one additional thing that we can see, if I go to the network tab, is when I vote, 2 pictures load in. But if I open up one of these pictures, Marowak's not one of the 2 Pokemon here. But if I vote on one, he's in the next 2. I'm preloading the next 2 images whenever you vote so that the next one can load significantly faster. If you hammer that button, it will be a lot slower. But it's way harder to get into that state. I'll even put us in slow 3G mode, and you can see that images will still load in pretty damn fast. I'm going a little faster than a slow 3G connection can do. But, and this is a big cool but, if I go to the results page, in slow 3G mode, it still loads almost instantaneously. Now, I should say instantaneously. That was what? 2 seconds? Yeah, 2 seconds load on a gigantic 490 row page. Being that fast is nuts. And right now it is fetching all of the images because they're all on this page. And now that it's done that, if I go back here, still in slow mode, you'll notice everything loads in instantly because all the images are cached now. So even on a slow 3G connection, this feels snappy as hell. Genuinely really happy with the performance that I was able to get out of this. So what does the code look like? Is this 100 times scarier? Is this just absolutely miserable to work with? No, it's actually a pretty good DX. I ran into a few issues around the Vercel deployment because of, how do I put it? Doing stupid bleeding edge things, as is my usual way. But once we smoothed those out, in particular caching on Vercel edge functions, once that was smoothed out, we got this to an insanely performant place. So let's hop into, I think I put this in stream. Yeah, fast around. Get status, get checkout main, get pull. I did add the rate limiter back too. Code here. Somebody asked why no Svelte, because why Svelte? I don't need Svelte. I had a stack that worked that I'm familiar with, so I use the stack that works that I'm familiar with. I guarantee my solution here is faster than a SvelteKit solution without like a lot of manual optimizations. So let's take a look at the code. This is an Astro project. I initted a vanilla Astro type-safe app. One of the magic points of Astro is when you fetch things in here in the helmet, it's TypeScript, so it's type-safe. So when I get my options here, it's read-only number, because getOptions for vote is a function that grabs first ID, second ID as 2 numbers as const, so I'm able to pass those over. Now I have a counter component, which you'll notice is a function component, which Astro doesn't have. How am I mounting this? This is a Preact component. I'm actually using a Preact.js file here, the vote component, and I'm importing that in Astro and mounting that with the ability to pass props to it, which is so cool. It is absurdly cool that I'm able to mount a component on the server and the client with the correct data and not have to worry about a hydration error. Because something you might have noticed on the version of this app, the next version, roundest.t3.gg, if you look at the console in dev mode, you're going to get hydration errors because it fetches a random 2 numbers on the server, doesn't pass those through as page props because I didn't want to use get server side props, and then it's not serialized on the HTML the client gets, so it fetches 2 different random numbers, and now it's a hydration error, which is obnoxious. This solves that by serializing the properties in the HTML as like a JS script so that they're accessible to the Preact code when it mounts in an incredibly minimal fashion. This is, I thought I'd have to do something for this all to work correctly. Nope. This gets these 2 numbers. Then if we go to the votes component here, I take in A and B are both numbers, and I set the current state as A, B as const. And then I have the next state as a separate state. By having these separate, I'm able to update the next state, start fetching the next pictures, and then update current once the user has selected their vote. I have 2 effects here. One goes through the current thing here and adds it to a has been fetched set I have out here, so that I don't have to keep refetching and instantiating new images every time a new one comes in, because right below it, I have this effect where I go through the next image, filter out ones that have been fetched, and for each new one, I create a new image, and then I set the source to the actual image URL for that image. And I do this for each next image to make sure they are in your cache by the time it comes up. This get image from mon is actually another hack I am pretty proud of. You'll notice /API/image mon.png. I wanted to get better Lighthouse scores, and GitHub's image hosting, which is what this was fetching from before, was not going to do that. And I didn't feel like setting up like Astro Image for this weird use case because I wouldn't be able to hit the right cached endpoint if the thing isn't mounted. And I just wanted to hack this out quick. So I made this, wait, no, that's the wrong file. I have API image id.ts. So I made this custom getter that grabs the ID, removes the .png, and parses the number from that fetch, and then fetches from GitHub the right sprite, creates a new body, updates the cache header, and then puts this in my CDN so it is way faster than fetching from GitHub. And once these are cached in my CDN, everything loads way faster. Really nice hack that I was impressed with how quickly I could set up. I'm sure that this is very similar to what Astro Image is doing under the hood. It probably does like the proper optimization using, what's it called? The one begins with an S that everybody uses, Sharp, the image package. Probably uses that to properly optimize the images. These are small images. I don't care about any of that. I just wanted the proper cache headers. So I did this to fix the cache headers. And now we have a significantly faster way to cache and fetch our images. Squoosh plus Wasm's in the works, according to Ben, who works on Astro. Super exciting. So one more thing that changed is that we're just generating numbers on client, and it doesn't seem like we're fetching anything. I showed you how we get the image URLs, but how do we get the names and other data that we need? Well, the reality is we don't need much other data. Pokemon ID number 4 is never going to change. So having that in our database is a tiny bit, I don't want to say foolish, but certainly unnecessary, because we know what Pokemon number 1 through 493 are. Again, this is why the things we're talking about here are not realistic for most applications, but due to the limited scope of how the Roundest voting app works, we can make the assumption that all of these Pokemon will always be the same. And as such, I could hard code all of their names in a file here in order. And if I +1 the ID of anything in here, that's the correct ID for that Pokemon. This made it significantly easier to have all the data I needed when the app immediately loads. Originally, I had this set up where I had the object that had the URL for the Pokemon, the ID of the Pokemon, and the name. I realized I could generate the URL for the Pokemon sprite. I can infer the ID from its index in the array. So all that's left is the name. So I made an array of names, and this is able to minify much better, drops into the JS that is loaded on the page instantaneously. So we have every Pokemon's information as soon as the page loads in the first HTML that goes down the wire, which is really nice. Having all of that included as soon as the page loads makes everything start significantly faster. And we're able to fetch from, or when we first load the page, this code runs on an edge worker. It gets the options, which are 2 random numbers between 1 and 493, passes those to this component, and then on the server renders the Preact component. So when the HTML comes down, the HTML is correct. Then the Preact hydrates that component, just that one component. And from there, Preact takes over just for the voting and starts fetching the next images ahead of time. That is it. It is very, very minimal now. I have one other endpoint that's important, the vote endpoint, where I have a SQL string that is, oh, it's actually not that long. So I insert into the roundestmon.vote table, ID, voted for, and voted against. The one annoying thing I had to do in here is, actually I had to do a couple annoying things in here. This file is probably the most annoying thing. So I have my Redis rate limiter here. That worked fine. I have the post function. This is an Astro route. It's similar to routes in NextJS where you have API / and you can drop whatever in there and that becomes a like JSON, like traditional endpoint. This file is doing the same. It runs on an edge worker though, which is really nice. But since I don't have Prisma on here, and I don't want to, I want this to be as fast as possible, I'm using the connection from reset. because I don't want Prisma, because it's nowhere near fast enough for what we're building here, I'm using the new PlanetScale database package that lets you hit PlanetScale's DB via HTTP from an edge worker. It just uses fetch under the hood instead of instantiating a Rust Prisma client to make a raw connection to the database. And that allows us to be much faster, both with how quickly we can spin up the edge and resolve a request, and also how quickly we can get that response back. So this, combined with the edge runtime, has made this part of the app, when you actually fetch, way faster. That said, it doesn't matter because it no longer blocks on the client. It just fires a fetch when you vote. If I go to votes.tsx, you'll see in here, vote for Roundest. I left the to-do. Don't need that there anymore because it has been done. But what you'll see here is I have the anti-vote, which is the one you didn't vote for. Then I post on the API vote endpoint who you voted for and who you voted against. And that's it. Then on the endpoint, I take the info that you sent here. I quickly test the rate limiter. If too many requests, I send a 429, I reject it. But then I get the JSON out. I run Zod to validate that you passed a voted for and a voted against value. And then I call the make vote function up here, which executes a connection, passes those two values from this SQL string. And I also have to pass a UID because Prisma doesn't auto insert those. But I generate a UID, I pass vote for, I pass vote against. This gets sanitized by the PlanetScale Connect SDK here. And I'm done. From all of this, I have now recreated Roundest and made it comically faster. Oh, there is one more endpoint. Results. I redid the results page as well. I had to write a SQL query. This one's a little bit longer. It was annoying because I wanted to aggregate and order things, and the order wasn't perfect still, so I do more in JavaScript. I execute that query. I manually cast a type because the Prisma database.js, the PlanetScale database.js isn't type safe. It can't be. It doesn't know the shape of your DB. There will be a Prisma adapter in the future where we can hack things around, but for now, it's not inherently type safe. So I built my own type definition here, cast the rows as that. I have a function generate count %. This takes a Pokemon, its votes for and against, and then it generates the, how do I put it? The percentage of its votes that are for versus against, so we can then rank them. I then sort the rows by their count percentage, and I have the get image fetcher. I should probably have reused a function in multiple places, but lazy. I can just Command-Shift-F for the string. And then I set a cache header. Here I create 5 minutes in seconds. I set that as the max age, and I set an SWR, which means if it has been longer than 5 minutes, you still get the cached page, and the next request will get a freshly generated version of that page. This allows you to always have a page that is in the cache, so it loads instantaneously for all users, even if they might get some stale data as a result of it. Result of this is that the whole app feels significantly comically faster. And if I get us a quick incog, turn off the slow 3G because that can sometimes screw up the Lighthouse. And it's not going to be straight 100s because of a dumb rule I don't know how to work my way around. I'll show you it momentarily. I still get a 92 out of 100 on best practice because I serve images with low resolution because they are sprites. They are pixel art. I can't do anything about that, Google. That is the nature of the pictures. They are supposed to be pixelated. I'm sorry. I can lie to you if you want and make them fake higher quality. But I'm not going to. So this will never be straight 100s because Google doesn't know what pixel art is. Anyways, that is how I made Roundest comically faster. I don't recommend doing most of these things, but if you do have situations where they make sense, a lot of the parts of what you saw here may be applicable. When you have problems that are very limited in their nature, when you have fixed numbers of things, when you have data that will never change, when you have a limit in the scope of the problem you're solving, encoding that limit in a performant way is a fun hack and side project, whatever you want to call it. It's not necessary, but when you have something as limited as this project, or a part of your project that is this limited, it is a lot of fun to over-optimize and make something that is blazingly fast. So I'll pose the challenge to our good friend Primogen, or anybody else in the community who wants it. See if you can make something faster than this. I'd be impressed, genuinely. You might make an endpoint that responds faster, but can you make an experience that for the user feels in all network conditions as fast as this one does? I would love to see you try, genuinely. Go make something fast. Try and make it fun too. Join the Discord if you haven't already so you can share it when you're done. Really appreciate y'all for this one. Thanks, guys. Peace, nerds. Somebody said in YouTube chat, add image rendering pixelated in the CSS and the sprite images look much better. Oh, that's a thing? Let me just HTML edit that quick. Image rendering pixelated. Oh, shit. Oh, shit. That looks so much better. Okay, thank you, kind sir. We're gonna make a quick change. Ooh, let's go through my actual workflow when I find something like this. Image render pixelated Tailwind to see if there's a Tailwind class for this. No, that's a plugin, which means there is not. So sadly, I'm gonna have to add a style equals image render pixelated. Let's see if that works. Run dev. That did not seem to work. Spec. Oh, the right image, right? Somebody said I can extend the CSS. I can, but I don't have any CSS written yet is the problem, and I don't feel like it. I would like to do this in rendering, or image rendering. Aha, that is it. Thank you guys. Thank you chat for reminding me how dumb I am. Really appreciate it. Seriously, that was very helpful. Really to do. Make images look way better. TY chat. I am actually very curious if that fixes Lighthouse. It'll take like 15 seconds to deploy, so we'll see in just a sec. I'm waiting to see if I can immediately see the difference when it loads with the new. Has not come in yet. Still very smooth. GitHub, Theo BR, faster round. Oh, built. Okay, cool. Now that works. Analyze. Let's see. That did it. Woo! Straight hundreds. Cool that it is that smart. Thank you so much for contributing 20 euros just to tell me that I needed to use a better image rendering strategy, James Craig. You're a legend. Thank you. Best YouTube message to date for sure. Got me a better looking website and straight 100s. Fuck yeah. Cool. So I made round faster and better looking. What a stream. And 20 euros. Good deals. Good deals all around. That's a flush. Yeah, straight up. Good shit. Yeah. Haven't been paid to be told how to fix something before. That's great. It's supposed to go the other way. I'm supposed to pay consultants. Yeah. Need to stream our code more. Actual legend. Shout out, James.